Okay. The primary goal for today is to go through some projectile motion problems so you can see how that stuff that we talked about in detail yesterday applies to an actual problem-solving scenario. Okay? And before we get too far, got to correct the date. Today's 28th. And it's Friday, and chicken tenders are $5. So last week it was a no-go. It was just the 8-piece chicken thing, which is still a pretty good deal. But so hopefully I'll get home quick enough so I can go grab some today.
Is it not every week on Friday?
It's not every. They have $5 Friday every Friday, but in the deli things kind of rotate through. So okay, so let's look at our problems here. Now I'm going to put all the ones down that are projectile motion problems, and then we are just going to target 2 or 3 of them and walk you through a setup, and hopefully you'll start to go, oh, I get how to do this. All right? So we have, here are your problems. 11, 12, 13, 14, and 15. And I will say that 11 and 12 are kind of duplicates because of the style of problem they are. So we'll look at one of those. But 13, I'm going to say 13, 14, and 15. If I was to say, do 4 of these, and if you're comfortable with them, you're good to go on this. It would be 13, 14, 15, and then one of 11 and 12. Okay, so as a quick review, because I'm going to have to erase this. Well, actually, can I squeeze it in? Let's see if we can squeeze this in. As far as projectile motion basics go, if somebody asked you what's the difference between what's going on vertically and horizontally as an object flies through the air, what would be the main difference between the 2 dimensions? I'm waiting. Okay.
X and Y?
Well, we do refer to this one as Y and this one as X. I'm thinking more of the behavior of how the object is moving in each dimension.
Horizontal slows down while vertical speeds up.
No. What kind of motion do we have horizontally happening that we mentioned? Constant velocity. What do we have going on vertically?
Acceleration.
Acceleration. So, if somebody asked you, all right, cough up all the possible equations that you might have to use. We got, that's the only one we can really use horizontally. And vertically, we have a whole bunch. Okay, and we pointed out that they're the same equations that we played around with during motion, our general motion units, but we needed to add an extra subscript as to whether this is whether it's related to the horizontal aspect of what's going on or the vertical aspect. And let's see, the second one was delta y 1/2 t VIY plus VFY. Then we had delta y equals 1/2 AY t squared plus VIY t. And then we had 2 AY delta y equals VFY squared minus VIY squared. This is where I said everything you need is here. So if you're into that mode where you're like, I just want to memorize exactly what I need to memorize in order to solve stuff, if you can't cough this up, you could be in trouble. Now, there is one additional thing that you need to be comfortable with, which is left over from the vector stuff. And that is if you are ever given a velocity and it has an angle, you need to remember that you cannot put the magnitude of a vector at an angle anywhere in these particular equations. And what you have to do is you need to use your vector capabilities to break this into Vx and Vy. Then these two are the things that can start to go in here. All right? So this idea that if you are given a V and an angle, you need to get to Vx and Vy before you can start to play with the problem. The reverse is going to be if a problem asks you to get this V, that means you have to use these equations to figure out what Vx and Vy are, and then you need to go through your last two steps of vector addition, which is the Pythagorean step and the arctangent step, in order to figure this thing out here. Okay? So this, I don't have all the math exhaustively laid out here, but this concept you have to be okay with. And remember all of the vector stuff that we dealt with when we did just pure mathematical vectors a few weeks ago. Okay? All right, so now I can kind of say everything we need is up here. So let's go for a problem. All right, let's just jump in with number 11. All right, so reading through number 11, and this one's nice because they actually put a picture in there as well, although it's on the next page. It says that the idea here is that it says somebody is throwing a stone horizontally off the edge of something. Now this is exactly what we covered yesterday. So if we're making a generic picture, we are on the edge and an object is being projected horizontally. Now what I am going to do here is I'm just going to list the values that are in here, and then I'm going to be asking people to tell me which one of these things are what they've given us. So they mentioned 18 meters per second. All right. They mentioned 50 meters. And that's it. Okay? So before we get into, all right, how the hell are we going to solve this thing? What variable over in this picture is this 18 meters per second? This is where you got to start to put the pieces together.
Vx.
Not VF.
Vx.
Oh, VX. There we go. I thought I heard an F and I'm like, no. Correct. This is VX because if they were doing this in the picture, and I don't know, they might have actually put this in the picture, they might list this and put it actually on the arrow. Did they do that? See, the fact that you're looking at it means you didn't look to see they even said that. Okay. What is our 50 meters? delta y. Okay. Be pickier for me. Because you are correct that this is delta y. What is going to happen during the course of our problem?
Will it become negative?
Correct. Technically, this will be a negative because our object is going to end up down 50 meters below. Okay? Now, these are the only pieces of information that they've given us. But there's two additional, I'm trying to think, yeah. There are two additional pieces of information that you're either supposed to figure out or know. What's one of them?
Negative 9.8.
Okay. Okay, and what variable over there is that going to be?
AY.
AY. Okay, what's the other one?
Velocity final.
Not final. Okay. What is it?
Zero.
It's 0. Why? What's the key word in the description that tells you this?
Because it's only starting with horizontal.
Correct. It said it is being projected horizontally. So from a vertical perspective, it's not headed up, it's not headed down at this instant. As soon as it's projected, that changes. But at the beginning of the problem, we have that. Okay. Now, this is where I don't even want to look at the problem. Some people like to look at the problem and say, figure out what you're supposed to find. I like to go over here and say, all right, what can we do? I have a Vx. So I'm going to put a little check mark there. I have a delta y. Now, granted, you are probably not going to use all of these in every problem. You'll probably just use one. But I'm going to check off everything we have and then ask you, what the hell can we do? There's delta y, there's delta y, there's delta y. We have an AY. And we have a VIY. Okay? And that's it. So now, in looking at these equations, if I just ask you, what can you do? And I'm gonna switch over to blue for this one. What can you find here? Okay?
Velocity final.
From which one?
From the default equation.
Okay? So this one, you could go ahead and find what VFY is. Okay?
You could also find T in the third one.
You could also find T in the third one. Now, I am going to start with this. Why does that look intimidating?
Because it's a quadratic.
Because it's a quadratic, and when you said, I could find T, I underlined two things. Why is it not so bad?
It has to be positive.
No. It does have to be positive, though.
Isn't the problem itself a quadratic?
Well, it could be depending if you're approaching it that way.
VIY is 0, so it's just, you just have to
This is 0, so this for this problem, this whole thing goes away. God, that's doable. Okay? So, over here, I really can't solve for anything in this equation, nor in this equation. But that's okay. Eventually I could. But in these two equations, I can find what VFY is from this one, and I can find what T is from this one. Now, can somebody tell me about one detail that you're going to have to keep in mind about VFY?
It can be positive or negative.
It can be positive or negative because we're going to have to square root when we get to the end. Can somebody tell me what we need to do there? back to the picture. What are we doing vertically?
Oh,
Which way we headed?
I'm going down, so you choose the negative one.
Right. So this will be, we will take the negative of this square root. Okay? Why the hell do we care about finding this t?
you can use it in the other problems?
That gets to come over here. So once we find this, I'm going to have to erase all this stuff after I'm done. That would give me that, which would allow me to find delta x. Now, in this picture, and I'm going to come back to this, I'm going to sketch this over the whole thing. We know that this thing is going to do that. What does the delta x represent in this picture?
Horizontal distance?
What?
Horizontal distance?
Okay. Okay. I'll go ahead and do this. Come draw a bracket to show where it is in the picture. Perfect. Okay. Now, VF, why? We know our object is going to end up here. This thing asks, what is the speed and the angle of impact? That's basically saying, what's the vector for this? Can somebody come add something with this here to show me how we figure that out from the picture? Should I draw this? Okay. What would we have to know in order to get the overall speed of this object? This is where we come back to this idea. With the green and the black here, which one is the overall speed conceptually? The black. So if I'm supposed to find the black, what do I need to know?
I think you need to know the direct path between the cliff and where it ends up.
No.
Angle?
No. Okay, I'm going to draw. Okay.
Well, would you just need Vx and Vy?
Correct. What's my Vx going to be here?
Delta x.
Vx. What kind of motion do we have horizontally in the x dimension? Okay. And how fast did we start moving horizontally?
18.
So how fast are we moving horizontally at the end? 18. What are we doing vertically?
Accelerating.
Which way are we headed?
Down.
Okay. I'll try and match that. Which y velocity is this? Okay, be more specific.
Minus velocity of y.
Correct. Which we told you you could find. That's my answer. What quadrant am I pointing in? 4. So if I follow my vector principles that we spent a week and a half learning, how will I get the magnitude of this black arrow?
Trigonometric. Or Pythagorean.
The Pythagorean step. How will I get my angle? Arctangent. And because I'm in the 4th quadrant, if I do this right, when my calculator spits out the answer, what will I do with that answer to get the appropriate angle, which would be that, what would I do?
Add 3.
Add 360. Okay? You guys get why I spent a week and a half saying, if you just know how to do vectors, we can say things like Pythagorean step, or for that matter, you could even say step 3, step 4. And if you really know what step 3 and step 4 are, you just told me how you're going to get the answer. Okay? You guys getting this a little bit?
Yeah.
Okay. So I'm not doing any more, but at least on this one. I'm going to leave this, you can leave some space and say, I'm going to finish that off. But can you see how you had to use all of this? You didn't use this exact picture, but you used your understanding of the relationship between the horizontal and vertical components of a velocity and the, the angled one. In this case, you got the two green pieces to figure out the black one, which was the answer. We will have problems where they give us the black one and we'll have to break this stuff down here so we can then substitute some of those numbers over into these equations. Yeah.
So are you taking the Pythagorean of the velocity?
Yes, only the velocities.
And that'll get you the speed?
That will get you the speed, because the thing is, they are asking for the speed at this instant here. Because the speed, and I guess technically they should say velocity, because the speed is only the magnitude of this black arrow. The velocity would be that speed coupled with this angle. And so if they say speed and angle, then they're really breaking it down, we want a velocity with a magnitude and a direction. Yeah.
So the velocity horizontally will always be the same. starting
Oh,
with-
I didn't write it up there. I had it up there yesterday.
Okay.
Constant velocity.
Okay.
So once if they give it to you, it never changes during the course of the problem. If you have to figure it out somehow, the moment you figure it out, it will never change, if you have subsequent calculations.
Okay.
So those are the things that I'm really pushing for you to get locked in, that if you're on top of that, you can work your way through this stuff. Okay, so I can erase this. And now, all right, so now I got to erase all this stuff. Every problem's different. People out in video land just get to watch me erase. Exciting. All right, so let's see. Now I'm going to skip 12 because I'm going to say the style of 12 is exactly the same, because they say there's a horizontal projection. But there's a different combination of variables that they give you, so you will work through all of this in a different sequence. But the idea of attacking it the way that we did last problem still applies. So now we're going to look at 13. Okay, 13. Tennis player, 12.6 meters from the net, hits the ball at 3 degrees above the horizontal. To clear the net, the ball must rise at least 0.330 meters. The ball just clears the net at the apex of its trajectory. How fast was the ball moving when it left the racket? Oh, this is a good one. Okay. Now, I would say right now that, because I don't want to spend too much time on this, I would say I want you to draw a picture of this for me and see if it looks right. Because if you can, that picture will be super helpful. I'm going ahead and drawing the picture. Here's the net. Relative to this, where does the ball start? As high, above, below?
Above.
We want, I got a yellow one. We'll make the ball yellow, since they're usually very fluorescent. Oh my God, nobody's gonna see that.
Oh.
Damn it! That would have been so cool. Okay. Let's see, and I'm using green over there.
Orange.
Orange.
Well, oh, orange. Okay. So we want the ball to barely clear the net right here, so it can get over to the other side. Over here, does it start higher or lower than this? If you interpret it correctly, it starts lower. So if I'm going to draw this in its original position, and I'm going to exaggerate this, it's going to be here. All right? Now this goes back to draw the picture right, and it really helps. It says, how far away from the net is this thing? According to the particulars.
12.6 meters.
12.6. So from here to here, we're talking 12.6 meters. Okay? What else do they tell us? This is where I'd really love somebody to come up and draw this in here. What?
It's 0.33 meters, or it must rise.
Okay.
0.33 meters.
All right, so I'm going to draw a dotted line here. Where's that 0.33?
Oh.
Okay? Now, in some of these cases, if you're going, I wouldn't have been able to do that. That's why we're kind of throwing this up here. Hopefully you'll go, oh, I get the idea how to play this game. And what else did they give us?
Angle.
They gave us an angle. And how did they describe the angle?
3 degrees above the horizontal.
3 degrees above horizontal. So in this picture, my angle, 3 degrees above horizontal. Okay? Now, in terms of variables, what is my 0.33?
Delta Y.
It is a delta y. And if I got really picky and said, what sign do you need to be sure that it has? Positive, because it's going up. So if we got really explicit here, we would make certain that that's positive, and we know that is delta y. What's this thing here? 12.6?
Delta X.
This is delta x. Okay? What is my 3 degrees?
Theta.
It's theta. Okay? Now I have 2 questions. And these would be the 2. 1, there is an additional piece of information in here that is really subtle that you have to interpret. 2, what the hell do we want to find in this picture so that we can kind of keep track of what our answer is? Okay?
How fast the ball was moving when it went over
Okay.
the thing.
What is representing that in this picture?
Vector.
Okay, this thing right here. And they ask, they don't ask what is the velocity, they just want to know how fast it is. So that means we don't need to worry about an angle because they already gave us the angle. Okay? Now, oh, this is going to be good. There's one other piece of information, and it comes out of the description. The ball just clears the net at the apex of its trajectory. Does anybody know what additional variable that gives us?
It means it's a quadratic, so it's -9.8.
No, not that we're not going to use the negative 9.8. Let me draw this for you. We already talked about what is the shape of any trajectory, since we're going to say it's going to be ideal. Reese?
Is it that the velocity is the vertical velocity is 0?
Bingo.
Okay.
Because if you have something, remember, if you're over here and we say, tell me what's going on there. It's moving this way, but it would also be moving this way because it's on its way up. And when we were over here, we would say, well, it's still moving that way, but now its y component is moving downward, and so it's, but at the apex, when you are just getting to the top, you've gotten to the max, you're not falling down quite yet, so the only thing you have is your horizontal component. And at this spot, I am going to say your Vy is 0. Now, if you are doing a horizontal projection, it's kind of like you're right here. And what did this 0 become if this was the starting point? Which specific Vy over there was it?
VI.
It was Viy. What will it be here?
VF.
It will be Vfy. Awesome! Okay, so the hint is Vfy equals 0. So now, and this is the part where some people who are super focused on, I know what to get the answer, you can rip through this pretty quickly, but I want to look at this like, there is so much you can calculate over here. We have a delta x. We got that. They gave us delta y. We have a Vfy. We have an angle. And we have one other thing that you mentioned, Liam.
9.8.
We have our AY of negative 9.8 meters per second squared. So that means we have this. Let's see. We have this, and we have that. Okay. So now, bring out the blue. Tell me, what can we find?
VIY squared.
Okay? Right here, we got everything but this. So we could find what VIY is. Now, it's squared, which means what's our last mathematical step?
Square root.
Square root, which means
Positive or negative.
plus or minus. What's it going to be in this case? Positive. Why?
Because
Back to the picture.
you're going to the right.
Not so much to the right, because this is y. So we're thinking vertically.
You're increasing by
You're headed, vertically speaking, upward. Not very dramatically, but you're headed upward. So that you, when you find this, you are going to take the positive. Okay. Anybody have some thoughts now? We find VIY. What could we do with it? Come on, come on, come on, come on. Put the pieces together. Okay, Ewan.
Find t, so equation 1 or 2 or
If we find this, we could put it anywhere else. There is a VIY. So we could put it in here, or here. And I would agree with you that if you're looking for the simplest one to find t, I'd go with this one. That allows us to find t. Then what do we do?
Find Vx.
Because now we can put it in here and find that. Now what do we have?
Well, we have Vx, we have the angle, so I think we should be able to find V and Y.
So we have this value from our initial calculation. That's this. By doing this second thing and getting t and plugging it over here, now we have Vx and we have this. If we have these two things, what do we do to get that? The simple, what most people will connect with.
Pythagoreans.
The Pythagorean step. Do we have to worry about the arctangent step? No, because they already gave us the angle. We're just supposed to find the hypotenuse. So in this scenario, we were locked into this. We had to find VIY. But then that allowed us to find t, which allowed us to switch dimensions so we could find Vx. Now we got the two legs of the triangle, Pythagorean step. We got the hypotenuse. That's what we're looking for. Bam! We're done. Now, I don't know if you were kind of mentioning something else. Anybody got a super quick way once we got this? If you don't see it, I'm not going to tell you. Because the truth is, this other way, I kind of like that one because it forces you to find the t. Because if you have to find some other aspect of this problem, you might have to find that t as well. So the idea that you solve this and go, oh, wait a minute, if I use that up here, I can get the time. I actually prefer that. But there is a shortcut here. But this goes back to that idea of vision. If you don't see it, you don't get to use it. God, I'm a bastard. Okay, let's see.
Is it, you only need to find horizontal velocity?
No. Okay, I'm going to leave it at that. Okay? I'm going to erase this. Let's see. So we're done with this. Oh, gotta erase all that crap again too. Damn it. Okay, number 14. I'm gonna skip because number 14 I think is real basic. If you're good connecting with the picture and these things, you can get 14 I think on your own. And we don't have time for 15 anyway. Damn it. Okay, 15 is another really good one, like this tennis one. And so we may take a quick look at that on Monday. Okay, just kind of go through a setup like this here. But I would encourage you to try this because remember, everything you need is over here. And so, you know, when I don't know if you guys ever get frustrated. If you guys ever watch me problem solve, you would enjoy it. Because when I get stuck, you would see me get so pissed at myself. There would be all kinds of expletives coming out, you know, like, you freaking idiot, what are you not seeing? You know, and I'd come back here and I'd be like, all right, what do I got? Right. So I always do this stuff to kind of help me put the pieces together. But when I get stuck and I'm missing something, God, I get pissed at myself. You know, because I'm like, I'm sure it's right there. And sometimes you just got to be willing to stare at it for a little bit. Granted, I don't know if anybody's ever done I need to walk away for a little bit and then come back to it fresh. That is also a strategy. But the only thing that I can really push on you guys for these 5 problems is that every single thing you need mathematically is in here. And keep in mind, when I say this part here, it's not just this picture, it's the concept of this picture that we spent a week and a half doing. So if you think and connect better, having gone through that week and a half, that's why we did it. Because that was not physics, that was pure math. But hopefully you can see its application here, all right? So you got your assignment, those 5 problems, and again, 11, 13 we took care of. Should be no problem. 12 should be fairly basic because it's kind of a duplicate of 11, but just with a different flow. 14 is pretty nuts and bolts. 15, I want to say, is a little bit like 13. And so I would say, if you think the picture in your head, great. But what I would really, if I had somebody come up and solve it here, the first thing I would tell them is, I want to see you draw the picture that shows what's going on. Because if you draw the picture right, some of the pieces of information that are important are actually in that picture. All right. Good Friday. Remember, $5 chicken tenders.